So our next speaker is a dev engineer at Mozilla. I'm like not really sure if I know what that is, but I think you'll find out.
Because it's pronounced dev engineer is how she said it.
Dev engineer. Yeah, we'll find out. And she's also done a bunch of cool real-time audio and graphics experiments. And she's even made her own entrance song, and it's called Get Submodules in an Old Django. So we'll see more about that. Welcome on stage, Solid Penadés.
Oh, we shouldn't. OK. This is going to take time, because I just built my own slide deck, and it's loading and decoding audio, music, and stuff. OK, and now we go full screen. This is all HTML. And now you're going to see and hear the full web audio and WebGL experience. That wasn't an MP3. That just happened to run in my computer. I had like 26 oscillators and filters and things synthesizing the sound in this computer. So I didn't have to download approximately like 300 Ks of music. I just generated that thing here. And that's the great thing. And I'm just going to switch out of 3D, and we go back to normal rendering. So the thing is that web audio is great, but it's also so different from everything you've seen before. And people are like, I don't know, I think I'll just stick to iTunes or whatever. And that's sad, because this is so powerful, and I would like everyone to learn this tiny new language. And the cool thing is that because it's tiny, it's got just very few words. That's the small vocabulary. And the grammar rules is essentially one. And then you only have a couple of idioms. And you know that for mastering a language, you need to master the idioms. So it's pretty easy, hopefully, after this talk, to master those idioms. And then you can go and create. And that would be great. So if you've done any graphics programming, you might have heard about the context. And we have the same thing with web audio. But in this case, it's the audio context. And I like to say that that's where we start, and that's where everything happens, because everything is contained in an audio context. And so the way we create an audio context is with new audio context. So you don't need to create a canvas and then request a context. You just create an audio context. And hopefully, by this time, even Safari will have stopped using the WebKit audio context. So we just need to say audio context. So that's great. And the other thing that you do from the audio context, because obviously with just audio context, that's boring, you need to do things with it. So that's when you use it as a toolbox, or as Java programmers would say, as an instance factory. But instead of like going for methods of 3 lines long, you just say create oscillator or create gain. I'm going to use AC instead of audio context because it's shorter, and otherwise it won't fit on the screen. So if you want to create instances of things, you just call audio context dot create whatever. And there is a list of things you can create like this. And I would like to separate things in kind of the type of nodes you can create. You can create nodes that generate sound. Other nodes manipulate the sound, like this manipulation column. And then it's just one sound for analyzing. But actually, you might not need more than that. So the other thing that the audio context does is it contains the audio graph. And so that's why everything is inside the audio context, both generating and like doing the thing. And here, I'm just going to talk about the only grammar rule, which is the connect method. So this is for connecting nodes together. You just do it with connect. Every node has a connect method, and you just call it and send the next node as the kind of like the argument for this. So that enables you to do modular routing, and that's super, super, super powerful, and way more powerful than just using audio tags. So, for example, I can start showing you a simple graph, which is one in which we create an oscillator. An oscillator is the smallest unit that can help us make some noise. And physically speaking, it's a thing that is physically oscillating between values. And in web audio, it just oscillates between -1 and 1. And the reason why it's those numbers and not 0 and 1 is because you want to be able to mathematically combine with them. So if they don't go under 0, it's hard to do some things. So we create the oscillator, and we connect it to the destination. The destination is the speakers. So That's how it would sound. You have an oscillator, and you have a destination. OK. But that's boring, and it sounds like a test sound. So what about we create the sound that the Mac computers do when we turn them on? So like we can connect many oscillators, everyone playing a different sound, and we kind of like. OK, so that's kind of cool, but that's a bit too raw, because I'm just connecting the output of the oscillators directly to the speakers, and that's a little bit too much. So in real life, you don't get like the output of synthesizer directly from the synthesizer down to the speakers. You tend to filter them, so they are a little bit more rich and interesting. So in this case, instead of just creating the oscillator and connecting directly the thing to the destination, I'm just going to insert filters in the meantime. And I think I use low-pass filters. I'll explain more about that. But you will see that the sound is going to sound a little bit less aggressive. So that's cool. So we've seen that we just created nice chords. We just create oscillators, create filter, and connect. So we could start doing fancy things already with this. But the other important idiom that we need to learn is the sound modulation. And this is the best thing. And if you're into like subtractive synthesis or kind of like spooky sounds, you're going to enjoy that part a lot. So what sound modulation means is that instead of just using stable values, we are going to use the output of nodes as data. So we are effectively using audio as input data. So that means that those kind of like wavy values that we're generating, we're like sending those things to other nodes. So instead of just saying oscillator.connect destination, we can say oscillator.connect to the property of another oscillator. That's what we call audio params or node params. Not all the properties in a node can be connected that way, but the ones that can are called audio params, and they are the most interesting thing of audio, probably. So the little issue here is, like, as I say, the sound sources only output -1 to 1. So suppose I am. So the problem is that if you just fluctuate between -1 and 1, that's not really very different from nothing of fluctuation. Like if I'm singing a note, like and I kind of like try to modulate it a little bit, like that's not really something you can notice. But if I want like, I don't know, like, wah, you can notice that thing. So we need something that takes this oscillator and makes it more like amplified. And the answer for this is the gain node. The gain node takes the input and multiplies it by whatever the gain property of the gain node value is. So again, we create it with create gain, with the factory kind of thing. And then we create the gain, we create the oscillator, we connect the oscillator to the gain, and you can connect the gain to the destination. So you can see the output of this filter or modified oscillator. And in this case, we are setting the value to 100. So what used to be -1, 1, now is -100, 100. So that's way more different. And for example, if I added a mouse move to this thing, I could control the volume of the oscillator by moving my mouse like this. OK. So you can see I'm just like changing the volume of the oscillator. So I'm amplifying it less or more. And we can, that's boring. But we can use this newly acquired knowledge to modulate things. So we can take a normal oscillator and connect another low-frequency oscillator to this normal oscillator so that we can get funny, spooky sounds. So they are called low-frequency oscillators because if you listen to them, like bare connected to the destination, you won't hear that because we can't perceive those frequencies. But when you connect them to normal oscillators, to the frequency, you can hear that difference. So it's kind of like an interesting physics human thing. So in this case, I create this low-frequency oscillator, and I doing this trick of connecting the gain in the middle. I'm going to make it oscillate between -10 and 10. And then I connect that thing to the normal oscillator that I created, but I connect the low-frequency oscillator gain to the oscillator frequency. So I'm kind of like, it's like connecting jacks between. And now I can see that the frequency is going to be like, whoa, 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 kind of like a flamenco thing. So this is the kind of effects you can create. So the yellow thing is the low-frequency oscillator, and the green one is the normal frequency, like the normal oscillator that we are trying modifying it. And now, as I change in X and Y, I can control the amount of modulation and the frequency of the modulation. So you want to get kind of like interesting nights, you can play with modulation, I guess. So I really like the corollary word. It like brings me back to my algebra classes. So I think it's important to just remember that you can build really rich things. Like this thing I just showed you only has 2 oscillators and a gain node. And you can build that thing with just 3, kind of like 3 nodes. And that's pretty cool. You can do that thing with audio, with the audio tag. So it's pretty interesting. So the thing that you need to remember is that if you connect one node to the other, it adds the values to the property, to the value that the property had already. But you can multiply things by using the gain nodes. So you can have this kind of like math going on in the graph, but you're not actually computing it. It's kind of like a declarative kind of like math. And that's so important to understand if you want to get like good performance for web audio. So speaking about performance, you might have heard that the web audio promise is that you will get low latency and sample accurate playback. But you might be like, how am I going to do this thing? And then you just told me that I just need to declare this graph and things will happen. So the way you do it is web audio has its own thread, and it's just like chugging along, doing its things. And what it does is actually just processes schedule events, or schedule events, as British would say, and just, because actually what it does is it goes through the list of events like super really quickly that it's happening in the graph. And the way you schedule those events is by using the node instances. So everything you create, every oscillator, every gain, some of the parameters can be automated because they are audio params. So not only can you connect things, but you can also automate the values. So you can make them linear ramp or curve or set the value at time. So you just kind of like schedule everything there, and then let web audio do it. Just don't worry about that. You can just like be super junky in your UI, but web audio will be smooth and great. So for example, you can say, oscillator, please start in 2 seconds, or please set your value for the frequency at 440 at 3.5, or ramp to that value at 13.5, or you can change the gain value, but not linearly, but exponentially. So you can get like kind of like different things programmed, and you can literally enumerate all those things at the beginning of your song, or I mean of your program, and then just leave it running, and it will just do the thing. And when it's done, it's done. That's it. So that's the way you should be working or thinking with web audio. And the graph is super optimized. You shouldn't be worrying about, oh, what if I add nodes or whatever. No, that's super efficient. And creating and throwing nodes away, that's super cheap because they're like actually not instances of like complicated things. They are like really optimized so that you can manipulate the graph and just worry about putting things in the graph and scheduling the things so that the web audio cannot. You know what Francisca explained this morning. You don't want to be changing between types and ifs and things, so that it's just like processing without like ruthlessly. And keeping track of a state is super expensive because you have to be like, oh, if the oscillator is dead, then create a new one. And that's not cool because you want to be like, the problem with audio is that you can't introduce junk. As soon as I get a little glitch, it's like, that sounds super bad. I'm pretty sure with native is better. So you don't want that. You want things to be smooth and like super responsive. So you need to make sure that the web audio thread is never interrupted. So tricks, don't keep references to nodes. Once you're done, just set whatever reference you have to null. Like if you have oscillator, say oscillator.null, so the garbage collector takes care of that. And also, make sure to stop and disconnect oscillators, because if an oscillator is disconnected, but it's still playing because you haven't stopped that, web audio has an idea that you might want to connect that thing later. So if it's active, it's like, well, still like processing or whatever, because that thing is oscillating. Maybe for your simulation, your physical simulation reasons or whatever, you want that thing to be continuous. So when you connect the phase, it's still the same phase or whatever. So it's not going to stop it. It's just going to be like keep chugging, and you might get things to be lost, like slow if you don't stop them. So remove references and stop and disconnect them so that everything gets clean after a while. And that's the basic rules that you need to take into account. And what else can we do? Because I'm just like giving you instructions, but I'm not showing you the cool things. So we can play existing samples. We can play more than just beeps. So the way you do it is because WebAudio just adds to JavaScript. It doesn't create new things. So you can load binary data with like, I don't know, like with fetch or cross request or whatever. And then once you have the binary data, you decode it. And whatever your browser can play, WebAudio can play. So that means that Safari can play OGGs. And once you decode it with a method that WebAudio gives you, with promises or callbacks, whatever you like, you can just use it. And the way you use it is you create a buffer source node, and you set the decoded thing as a buffer, and then you can fire as many as you want. So suppose we can magically load and decode this binary thing, and then we just create the buffer source, set the buffer, we connect that to the destination, and start it. And we get the aiming loop. So that's cool. But that's fine. That's what we can do with the audio tag without all these kind of like magically decoding things. The interesting thing is that it's got properties like a playback rate, so you can do pitch bending. So it's a audio param, and I can set the value whenever I want. So in this case, I'm going to pitch bending using the mouse. So I can go slow or fast. And you can like have your happy hardcore parties or whatever. OK. So that's starting to get interesting. And now, suppose you want to build kind of like some music software. You know, like when you listen to music with headphones, some things are on the in your left, or in your right. So you might want to be able to like build something that happens to be spatialized. So for this, we have the stereo panel. And the way you create it is to create a stereo panel. And then it's got the pan property, or audio params. So if you set it to -1, it means that it's to your left. And if it's 1, it means that it's to your right. So with that, I can do things like hypnotizer. So you're just like, hopefully, it should be working. I don't know if it's working. Is it stereo? So you're going to do whatever I say. OK. Everyone should use Firefox. OK. So that was cool and great. But now that VR is coming with Firefox, so you can be like creating interactive experiences with your Oculus Rift and like new worlds and everything. And when you're in the real world, our ears have the shape they have because we can listen to things in 3D space. So I can notice, due to the way the frequency rolls off and everything, that something is behind me, or that someone is up there, or whatever. So 2D is fine, but it's pretty simple. And when you're doing like these kind of 3D experiences or games or whatever, you want things to be a little bit more immersive. So we can use the panel node. And it's cool to stop for a moment and understand how it should work, because this is a bit more involved than just setting the pan property. We have a listener. Every audio context has a listener, for simplicity. And then everything you want to position, you have to connect to a panel that you create with create panel. So this oscillator should be positioned in space. Then the listener and the pan things, all of them have positions. They also have velocity and direction and orientation. But for simplicity, I'm just going to say position. So what you need to do is every time your game is updated, or your VR experience or whatever is updated, you need to make sure that you update everything. Because otherwise, you're going to be showing something on the screen, and that thing's not updated, so you might not even listen to the things. So yesterday, we saw birds in WebGL. Today, I bring you 3D birds with sounds. So hopefully that might work. I can listen to that. The speakers go to your way. But yeah, you can do these kind of things. Every bird has a panel node, and sometimes it chirps, because you know that chirps. I mean, birds are not like blah, 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 blah all the time. So the listener is where we are, which is the camera. So when the slide moves around, I'm moving around as well, the listener position. This is how you can make games. It's super easy. If you try to do the same thing with OpenAL or everything, you need to load the libraries, the bindings, like vibe with that, and it won't be multi-platform. But now we have 3D sound in the browser, and it's so cool. So that's cool. And then we have the filters, which is, I showed you a bit of that before. So that will just let you some frequencies pass. So this is what DJs do when they try to be fancy. So you create the filter, and then you can like go play with the frequency and kind of like be super, super cool. Oh, also, you can have different types of filters. I think if you're in drugs or something, this is way cooler than it is now. So anyway, so it's kind of like a party, but you know there are no parties without visuals. So how do we do the visuals? For this, we can use the analyzer. So that lets you kind of like look into what's going on in the node, and it will give you either real-time frequency or time domain information. So the real-time frequency is the fancy bars, the spectrum bars, and the time domain is the wavy thing, kind of like when you say oscilloscope, it's like what you think of. So this works slightly different from the previous nodes, and that's for performance reasons, because you need to allocate some space for the results of the analysis before. And in this case, I'm using an unsigned integer bytes thing array, but you can also use float arrays. I don't really know why I use this one. I think I just copied that from code that I made before, but you can use both. So you create the analyzer, and then you connect whatever you want to analyze to the analyzer. So you say buffer source, which is my aiming loop, connect to the analyzer, and then I connect that to the destination, and the sound just goes through. So it's fine. It doesn't really modify the sound. But every time you want to get results, you call this get byte frequency data and send it the byte array that you created. And again, you don't want to give it bad kind of like types of array. If you give it a uint array, it knows what type it is, and it's going to be way faster. So you need to be aware of these kind of things. And once you get the results, you can do whatever you want with them. You can plot them, or you can do like fancy 3D things. In this case, I decided we just go with a normal line. So you can see what effect the filter has is because it's like cropping all the higher frequencies. And if I change to another type of filter, I'm cutting out the lower frequencies because this is high pass filter. And I can also show you the time domain thing. So, well, yeah, this is the time domain. So this is the wavy thing. So you could do 3D things instead of this simple thing, but I thought this was more aesthetically pleasing, and you have to keep the statics. Aesthetics are important. Please, everyone, remember that. Don't make ugly slide text. So wrap up. This is minimal and it's powerful. I just show you a little bit of what you can actually do, but there are many other things you can do. Like you can add echoes and delays, and you can like do pretty cool stuff with this. With just this little one graph and simple connect rule, because there's only one rule, connect. And you can do all this sound generation and processing and analysis. I've seen so many types of things done, I can't even start to show you. So I think this is also great for games, because obviously you can get like great performance and like all this spatialization, and like things are really on time. Whereas if you try to do the same thing with the audio tag, it's like, I hope it plays. So you kind of like fire, and 3 seconds after you get the bullets, and you're like, what is this thing? I don't understand. So this is what you should be doing if you're building games. Stop using the audio tag. If you do it and just knock you or something. If someone else comes, oh, I tried to use audio and it didn't work, and probably, yeah. So use it, and you will see that it's also fun. Like when I was building this thing, I would be like in the office, like, and people were like, "Why are you not coming for lunch?" No, I'm just having fun here with the audio. So it's really interesting. Like everyone I send this slide, they have spent time playing with the modulation, and it's like super simple, and it's just like again 2 oscillators and a gain node, and it provides so much satisfaction. Who wouldn't want to have provide satisfaction to their users? I mean, if you don't, I think you should consider changing careers. So it's also fun. And now that you got the basics, you should go and explore and make it your own. Because I use it the way I like, but you might be interested in other aspects. Some people played with building a bit detector. Other people built a thing for like centering the signal and making sure that the thing was properly okay. So it's up to you to do whatever you want. And the cool thing is that not only is it easy to build, but it's also pretty easy to distribute. If you try to do any sound processing thing in the past, it's horrible to get it in the hands of the people. Like, they have to install binaries, and that's the worst thing ever. But you can just like give it to people, and then you can just play with things in the browser. And the best thing is that it even works in iPads and that kind of things, so you don't need to like do native iOS things. So it's pretty cool. You should come to the web audio meetups. So we have one in London that I know. I help organize that one. And then I know that there is another one in Berlin. If there is not one in your city, maybe you want to organize one. Just come to me, and I will try to remember how we did it. But basically, we just got people there. We talk about audio, very rarely web audio, because apparently no one does it, but everyone is interested. We talk about peer data, like the sonic arts, which is kind of like super trendy. And the last time we had someone come and explain us how do you categorize flamenco music depending on the sentiment and that kind of thing. So it's all pretty meta and pretty interesting, and I think that's super opening your minds, and that's super cool to be doing. So yeah. Thanks.